everyone. Vanakkam, Swagatam, Namaskaram, and I welcome you to the Machine Learning Basics, and I am Dr. T.S. SUBASHINI, belonging to ANNAMALAI University, and today we will be talking about the basics of machine learning. So, first we should understand the difference between AI, ML and DL. AI is a superset and machine learning comes under AI, and deep learning is once again a subset of machine learning. So, when we talk about deep learning is with regard to neural networks, and machine learning we are using some statistical algorithms to process data, and AI is a set of algorithms which is trying to imitate the human brain and behavior. So, what is machine learning? So, you can see a human there. A human says I can learn everything automatically from experiences. Can the machine learn? The machine says yes, I can learn. Suppose I am given some past data, I can try to mimic a human with the help of machine learning. So, machine learning uses various algorithms for building mathematical models for making predictions using historical data or information. What is machine learning? With the help of sample historical data, which is known as training data, machine learning algorithms build a mathematical model that helps in making predictions or decisions. So, what we have got some data. So, that is called the past data or historical data. That data we are going to use as a training data, and using these algorithms I will be able to build a model, and that model will be able to make predictions and decisions. Machine learning is not a single discipline as such, it is a combination of computer science and statistics. So, they are combining together, they are trying to create some predictive models. So, when you have got more of training data, we will be seeing what training data is later, the higher will be the performance will be improved. Okay. So, if you see this block diagram here, we can say that the input data, that is the past data or historical data, that is given as training data to the machine learning algorithm. Machine learning algorithm will learn from this data, and based on this data it will build logical models. Okay. These models which is used to predict your data. For suppose I am going to have a new data that is going to predict what kind of data it is based on the model already learned. Okay. So, what is the need for machine learning? So, what is machine learning? We understood machine learning is, it is trying to mimic a human being. So, like how humans make decisions based on data, machine learning is going to make decisions based on data. So, machine learning is capable of doing tasks that are too complex for a person to implement directly. So, as a human being we can make some predictions, but we cannot work on huge volumes of data. So, we have got a huge amount of data. To process the data manually is very difficult. So, what we have got some limitation that is taken care by the machines, or machine learning is able to do those complex data analysis. Okay. With the help of machine learning we can save both time and money. Then applications of machine learning, where all we can make use of machine learning? We can use machine learning in our daily lives, like for example, these are some of the areas like image and speech recognition, medical diagnosis, statistical arbitrage. What is arbitrage? Arbitrage like financial assessment, like a financial trading. So, all those equities, all those things comes under statistical arbitrage. Learning associations. What is association? Like if then this, that kind of association. If I have this today, if it is raining, tomorrow I may get flood. So, this kind of associations is called as learning associations. Then it is used for classification purposes, categorization, predictions, forecasting, extraction, regression, and all these areas we can make use of machine learning. And what is a machine learning framework? So, as I told you, our intention machine learning is to create a model. So, based on data, the machine or the algorithm is going to create a model, and that model, for example, is called a function. Okay. We are representing this using this f. I am representing this using this f. using this f. F is a function which is operating on the image. For example, image is my input. So, from the image I will extract certain features. For example, this is an apple, next we have got a tomato, next we have got a cow. From the apple I can extract certain features like what is the shape of the apple, the color, the texture and so on, and those features are given as input to the machine, and the machine is going to find out a function. That function is to give the answer, namely apple. So, our intention is what? Using our algorithm I should be able to arrive at a function, prediction function, in this case f. Similarly, I am going to have a function which is going to predict tomatoes. Okay. So, once again I will be passing certain features. I am not going to pass the entire image. Suppose I want to pass the entire image, what happens? I am going to have more number of computations. The computation is going to increase, or complexity of the computation is going to increase. So, what I do is that I am going to give the tomato, instead of giving the entire tomato as the feature to the particular algorithm, I will give only certain features. For example, what is the color of the particular object, what is the size of the particular object. Likewise, I will be giving certain features. Based on these features, I have to obtain a prediction function, and that function should give the result tomato. So, once I obtain that function is called the model. Okay. Similarly, for cow, in this case for the cow, instead of giving the entire cow image, I can take features of the cow like how many legs it has got, what is the height of the particular animal, what is the breadth of the particular animal. Like this I can get, for example, I am telling you, you can take certain features, and using those features I will be able to arrive at a function, that is this function, say f. So, for this cow a model will be created. For similarly for tomato a model will be created, and similarly for apple a model will be created based on the data given to the machine. So, when I am going to give when I want to create a model for apple, I should have thousands of apple images given to the machine to and make it understand. See, for example, when I want to teach a child what is an apple, okay, I want to teach a child what is an apple, what I do, I will not show a single image, I will show several images of apple, and after seeing several images of apple, child will understand, okay, this is apple. So, whenever I show the apple, the child will be able to recognize that to be a apple. Similar case also in the case of machine learning. So, when I want to create a model for apple, I have to give several samples of apple to the machine, train the machine, and after training the machine will be able to create a model for apple, able to understand. So, similarly for tomato, similarly for cow. So, machine learning requires a number of samples of the object to train it. So, this is a see, suppose this is a image given to you. I want to one thing I told you, we are not going to take the entire apple or entire tomato image or entire cow image as input, because we can see how many pixels are there, how many image values are there. If I am going to train the entire image, it will take longer time for the machine to converge. So, what I do, instead of giving the entire image, first step is I am going to crop only that motorcycle. Okay, this is the motorcycle I have cropped. So, after cropping it, so even this I do not require, even I have removed the background, even after removing the background I do not require the entire thing. What I do, I then take features like this. I am going to segment, as you can see the green color outline, that is segmenting the motorcycle, and from this segment once again I not need the entire thing, I want only what? I want only the certain features. So, how many wheels are there, so where is the headlight, where is the tail, where is the engine. So, these 4 different features is sufficient to categorize this to be a bicycle. So, that is the idea of segmentation and feature extraction. So, instead of giving the entire whole image as input to the machine and get the data trained, what I do is first I go for cropping using this red outline. I have cropped it, and then I have used this green color. Can you see, this is for segmenting, and then these are the features which we are going to use for identifying that to be or categorizing that to be a motorcycle. Next is features. So, what is a feature? So, we saw here this is the motorcycle image. Okay, assume this is a motorcycle image. From the motorcycle image I am going to take useful features, as I told you, the number of wheels, the number of where the engine location is placed, the head and the tail and so on. These are meaningful features. So, in this particular example, this is the feature. For each application the feature is going to vary. So, I will be applying some feature engineering or some techniques by which features can be extracted, and these features are given to the machine learning model. So, the machine learning model then using these features will be able to categorize that to be a bike or that to be a car. That way it will be able to categorize. Okay. So, what is a feature? Feature is choosing informative, discriminating and independent features. We have to choose informative, discriminating and independent features. That is an important step for effective algorithms in pattern recognition, classification, regression. Suppose I take wrong features, means whatever process you are going to do after this, this is going to be a problem. So, you have to take very good features. Only if you are going to take good features, you are going to get correct classification results. Okay. So, what are the features are normally, so what do you, I told you features, in this case I told wheels and other things, but generally we do not take that kind of features, we take raw pixels itself, the entire image itself as features. I told you raw pixels, the pixels in the particular portion itself as a feature, or I can take some statistical features, I can take the mean, standard deviation, variance and all those things as features, or I can take some shape features like area, eccentricity and something like that as features. So, when I say features, for understanding purpose, I told you the leg, how many legs a cow is having, how many wheels a bike is having. So, these are some to understand things, but generally when I talk about features in machine learning, they may be statistical features, shape features, texture features and so on. There are so many features available. Okay. Okay. So, for example, see, as I told you, features cannot be fixed. For each and every application, the features are going to vary. So, for example, I am going for character recognition application, then the features will include how many black pixels. So, this is, I am writing like this is my stroke. So, what is the stroke? What is the orientation? For example, what is the orientation? What is the length of each character? So, what is the number of pixels in this? So, number of pixels is more, means I can think that to be D, L, H like that. Suppose the number of pixels is less, means it is maybe A, C like that. Okay. So, this way I will be having features. I will be counting the number of black pixels along the horizontal and vertical directions, maybe stroke detection and many others. So, those will be features in the case of character recognition. Then, in the case of speech recognition, I have to identify features for recognizing the phonemes. What is phonemes? What is phonemes? Phonemes is like A, O like this. Whenever talk, the sound signals which we get, no, that is called as phonemes. And for recognizing those phonemes, we should know what is the pitch of the sound, noise ratios, length of sounds and so on. So, these are the features in the case of speech recognition. In the case of spam email detection, the features are going to vary. For example, we include the presence or absence of certain email headers, email structure, the language used, the frequency of specific terms, certain terms will be repeatedly used, the grammatical correctness of the text and so on. So, these are some of the features in the case of spam detection. In case of computer vision, image processing and so on, there are a number of possible features. So, some features may be edges and objects, some can be edges and objects. Okay. So, next is we will go on to the machine learning framework. So, in the machine learning framework, it is put in terms of mathematical representation. We have to find, I told you initially, we have to find out the function f. Okay. So, this is the input sample given. This is for example, cow, tomato or apple, which whatever it is given, they are going to give samples. For example, x1, x2, x3. X4 and so on. So, there are so many samples of apple, x1, x2, x3 and so on. These will be given to this function, or I will be able to arrive at a function which is going to predict the value, namely y, namely apple. Okay. So, what I have to do? I have to give several values of x. X is nothing but your samples, training samples, say apples. I will be giving several apples, and these apples will be given to the machine. And this, after learning the various features, I will be able to arrive at a function. In this case, we call that to be a model. Okay, we say it is a machine learning model. A model has been created for apple. Similarly, I have to find this function. So, what is y? Y is your label. Label means your target. Target is apple. Okay, label is, target is apple, and x is your features. X is your features. That is what this y is equal to f of x. Y is equal to f of x. Y is equal to label and x is your features. Okay. Here x are independent variables. X are what? The independent variables. Based on the value of features, my y is going to change. Suppose I say this is the feature, this can be cow. this is the feature. So, based on this can be an dog. So, this is a independent variable and this is your dependent variable, y is your dependent variable. Okay. So, what is training? Training is giving as a training set of labels. So, we have got labeled examples. What is the meaning of this x1, y1? What is the meaning of this? x1 is set of features followed by the label. If I have this features, this is a cow. So, y1 is cow. Okay. This is y1. So, this is x1 is set of features for the cow, number of legs, the length of the animal, the height of the animal and so on. So, this is x1 and y1 is the label, label is the cow. Suppose I take x2, y2, what is x2, y2? For example, x2 is the features and y2 may be say cat. So, this is y is label and x represents the features. Okay. So, what is training? We have to give a labeled samples, we have to give labeled samples to the machine and the machine is going to estimate the function f. I told you it has to identify a function f, and when I am going to identify I have to arrive at the function f, and I am going to arrive at the function f, at the same time the prediction error should be minimized, minimizing the prediction error on the training set. Okay. So, you have to minimize the prediction error. Okay. This is the idea of machine training. Testing. What is testing? So, once I have obtained a function f, I can use this function to predict new data. For example, here I do not give any label, I do not know whether it is apple or orange, I do not know anything, I simply give an input to the machine. Okay. Let me erase it. Okay. Okay. So, here suppose I have got a function f, I have obtained a model for apple. Okay. Assume I have obtained a model for apple. Similarly, I obtained a model for banana. Like this, I have got three different classes of fruits, apple, banana and orange. Assume like this. Okay. So, I have got one model for apple, say let us say FA. Okay. One model for banana, FB, then one model for grapes, say FC. So, I have got three models FA, FB, FC. So, what now I am going to give a test image. I am going to give a test image. Test image, say for example, I am giving a banana. So, okay, I am giving a banana like this. So, what happens? I will take the features from the banana. I will pass it to the model FA. I will pass it to the model FB. I will pass it to the model FC. Okay. Since this is a banana, this model will give the correct result to me. Okay. Since this input image is a banana, this I have compared with all the models of apple as well as banana as well as grapes, and because this is a banana, the features will match with this model and my machine will say this particular input is a banana. This is how it happens. Okay. So, first what we should do in the case of training, we have to give all the training samples to the machine and along with the label. When I say label means the category to which it belongs. For example, I give these features, I say this is apple. I give these features, I say this is banana, like this. I will be giving all the samples and I will be training the machine. Once I have trained it, I will be obtaining a function f. Okay, we call that to be the model. So, as we told you in this example, we have got three fruits, apple, banana and grapes. So, for example, FA is the model created for apple, FB is the model for banana and FC is the model for grapes. So, whenever I am going to give a new test image, I am going to apply F on a never seen test example X. So, I do not know whether it is apple or banana or grapes, I do not give any label, simply I give the input, the machine will be able to compare that with all the three models FA, FB and FC, and whichever model gives the best result or best score, then I can say the test image is particularly namely A, B or C. Okay. This is the idea of this one. Then machine learning life cycle. Machine learning life cycle, if you see that the various steps are gathering data, data preparation, data wrangling, analyzing data, training the model, testing the model and finally deployment. Okay. So, first step is we have to gather data. Gather data we know. So, unless we have data, there is no point in doing any analysis of the data. So, gathering data is understood. Next is data preparation, like we have to reduce the we have to add the missing data, we have to make sure data is validated data and so on. What is validated data? For example, I am trying to enter the age as 200 of a person. Age cannot go beyond 120 or 130 to the maximum. Okay. So, suppose I am entering say age as 200 means it is wrong. So, I have to validate the data. I should check whether there is any mistakes in the data, any deliberate mistakes or accidental mistakes, or whether there is any some invalid inconsistent data and so on, all those data should be removed and cleaned before data can be passed on to the next step. Okay. Next is data wrangling. Is like once you make the data ready for analysis, at the time of analysis if you want to do some changes, that is called data wrangling. Data preparation is not even before analysis, we have to prepare the data, and data wrangling is what? At the time of analysis, in case at the time of interactive analysis you want to do some modification data, that is called data wrangling. Then after which you do analysis, then you analyze the data and you then train the model. Once you train the model, you get the model created for each and every category. For example, as I told you, for apple I got one model, for a banana I have got another model, for grapes I have got some other model. So, I will be having model obtained. So, once I have the model, I can test the model using some input data or testing data, that is called test model, and finally you can deploy this machine learning algorithm anywhere. Okay. We can train machine learning algorithms by providing them the huge amount of data and let them explore the data, construct the models and predict the required output. That is what we discussed right now. So, we have to have, so whenever we are, as I told you, whenever we want to create a machine learning algorithm, the first step is we should have huge amount of sample data. Only if we have the sample data, then only we can make the machine understand better, then we will have a better model created. So, whenever we talk about machine learning should have large volume of data for training purpose. Okay. Next is types of data. So, when I talk about data, there are two types, one is qualitative and other one is quantitative. Qualitative is what, like which you cannot measure, and quantitative is something which you can measure. Example of qualitative data, for example, we can say I am very happy today. How do you measure happiness? I am very sad today, you cannot measure that. It is very cloudy, how much cloudy it is? It is very sunny, how much sunny it is? That is very difficult to classify. And once again, if you take qualitative data, we have got nominal data, ordinal data, and quantitative data is categorized as interval data and ratio data. We will see there what is that. Nominal scale. So, what is nominal scale? I can simply give some value. This is variable A, this is variable B. It can be a numerical variable, it can be a name variable. For example, name is SUBASHINI. So, name is one variable. Now, for example, some value is 5 is another variable. It can be either numeric, it can be either thing. It has got no ordering. We do not have any ordering there. Anything can be given. That is called nominal scale. When I say ordinal scale, we can see there the different expressions given there. How satisfied are you with your service? Something is given like this. We can see this frowning face, we can see a happy face here. So, here we do not have any kind of values for that. It is subjective in nature. It is subjective in nature. We can say I am happy with the product, I am not happy with the product. That way we can give some sort of a sentiment analysis, sentiment kind of thing that we can do. Next is like a rating in a scale. For example, how do you rate your university? Okay, we say 1, 2, 3, 4, 5, 6 scale. So, we can give some scale. So, but scale is once again some order. 1 means lower order, 2 means better, 3. That way we can give some kind of ordering. That is called interval scale. And ratio scale. So, how much idlis we had in the morning? I had 2 idlis. How many those are? Maybe 3 or 4. That way we have some sort of an variation. At the same time, we can have kind of a ratio that is called as a ratio scale. Once again, there is ordering. When I say 4 means definitely 4 is a bigger number compared to 2. So, there is some ordering, but need not be a fixed value, that is called a ratio scale. So, these are the various kind of data that can be processed using your algorithms. Okay. So, going back to data preparation, so what do you mean? I told you already, we have got missing data, we have got noisy data, and we have got inconsistent data. So, what is inconsistent data? For example, I have got a table, assume like this, I have got a table, and say a person is leaving the university, okay, a student has joined computer science and engineering, assume like that, and he wants to leave the university in the middle, in second year he wants to leave. So, his data will be in the computer science department, his data will be in the dean's office, his data will be there in the administrative office also. So, whenever I want to remove data, I should remove in all 3 places, yes or no? Otherwise, whatever data is available will be inconsistent with the data already available in the computer science department. So, a person is leaving an institution, the data wherever his data is available throughout the institution, that data has to be removed, then only it will be a consistent data. That is what I mean by inconsistent data. So, we should, whenever I am preparing data for analysis, I should not give any inconsistent data to the algorithm, because whatever result I get after running the algorithm will be wrong. So, data should be perfect cleaned, there should not be any noisy data, there should not be any missing data. So, there are techniques. So, there are so many techniques available for cleaning data. Okay. So, we are not going to details of this. So, for cleaning itself we have got a number of techniques available, okay, pre-processing techniques available through which data can be prepared and made clean, and that could be useful for the next step processing. Okay. The next is data wrangling. I told you what is data wrangling. Data wrangling is a next step next to data preparation. Before the data could be analyzed, I have to go for data wrangling. So, what data wrangling means, like for example, there is one example I will try to give you: outlier detection and removal. Outlier detection and removal. So, what is an outlier? See, some for example, as I told you, some data regarding height of students, okay, some data regarding height of students. Okay. So, we give some data, say 2.1 feet, another one is 6.7 feet, another one is 9.10 1 feet, okay, I show that. Then one something is 0.2 feet, like this. Okay. So, what do you think could be outliers here? So, normal height of a human being, suppose studying in first year BE, that could be starting from 4 feet, okay, 4 feet maybe up to 7 feet. Okay. So, this is within the range in a class, 4 feet to 7 feet would be some height of students studying in a particular thing. But when I say 2.1 or 0.2 or 9.1, these are called as outliers. These are noise or unwanted data that is not going to be of any use to you. So, we have to remove those outliers. That is what I mean by outliers. So, what is feature selection? Once again, I told you, if I am going to take an apple, means I am not going to give the entire apple as input to the machine. I am going to take certain features. Okay, I am going to take certain features. Maybe initially I took 10 features from apple. What is the size, shape, color, texture, all those things. What family it belongs to, all those things I am taking as features. After which I can think these features are repeated features. So, I will make this only 4. 4 is sufficient. Instead of 10 features, 4 is sufficient to classify that to be an apple. There is no need of other features. Other features are redundant features, unwanted features. It is not going to help me in classification. So, why you want to have 10 features? I will go with 4 features called best feature selection. So, all these comes under data wrangling. So, it is not pre-processing, it is the next step before you can go on to the analysis phase. Okay. So, once you have done this thing, you have to divide the data set. So, I told you one set of data will be used for training the algorithm, another would be for testing the algorithm. So, this is for training. So, what I do, the entire data set, for example, I have got 1000 samples, I have got 1000 samples, I will be using 70% for training, okay, 70% for training and 30% for testing. I will be using 70% for training and 30% for testing. Okay. So, this is your about your data wrangling. So, now data wrangling is over, you have gathered data, you have pre-processed the data, you have then done data wrangling, then I have to convert the images into train images and test images. So, you have got the training images here, you have got the training images here. So, what happens? I am going to extract features from the, I told you I am not going to give the entire image, I am going to extract features and also I am going to supply the label. So, if these are features, then this is apple. Okay. So, this is what I mean by, for example, if you take the cow, if I take the cow and give us features, then the label would be cow. If I take the horse and give us features, the label would be horse. So, I will be giving features, I will be giving the training labels. So, then I will be training it, and once I have trained it, after some time, after training using several samples, I will be obtaining a model for cow, model for horse and so on. Okay. So, model will be created. Now, what happens? This is training is over. For each and every object, a model will be created. Now, test image here, can you see I am not giving any training label, I am not going to give the label to the machine. Okay. Simply I am giving the test image only, the machine will extract the features and these features will be compared with all the model. Compare with cow, compare with horse, compare with apple, banana, pear, whatever it is, will compare with all the model, and whichever model gives the best result, that is your prediction. That is your prediction. For example, this is apple, the apple model will give good result or good score. So, this will be the predicted output. So, my machine will say, okay, this is apple. Okay. Instead of I am not giving any training label here, can you see I am not giving anything here. Without giving this, based on the already trained models, my machine is able to predict that the given input is apple. Okay. Suppose the machine predicts this to be tomato, suppose the machine predicts this to be tomato, this is what? Wrong prediction. or it is what, or the machine is failed in making the prediction correctly. Okay. Okay. So, now we have understood what is machine learning. Machine learning basic step is what? You have to train the machine, create a model for the particular category, and when we give the test image without the label, the machine is able to identify. Okay. So, once again machine learning we are classifying into 3 major categories: supervised learning, reinforcement learning, and unsupervised learning. Okay. Unsupervised learning. So, supervised learning. So, what is supervised? Like a supervisor, we are going to also give the label. Okay. I am going to say, see, I am going to give these inputs here. Can you see apple? I am giving the input, not only the images I am going to give, I am also giving the label. These are apples, these are apples. So, I am going to do the supervised training. I am also going to say, okay, see this is apple, see this is apple, this is apple. Every time I am going to tell the machine, I am telling this is apple, this is apple. So, now what happens? This is a machine, the machine is going to create a model, and it is after seeing several samples, the machine is able to create a model. And now, when you are going to give a test image, so this is your test image, I am going to ask what is this to the machine. Okay. What is this to the machine? The machine immediately goes and compares with the model here, and says that okay, it is apple, it is giving the prediction apple. Okay. So, this is how it happens. So, supervised learning algorithm is classified into 2 types, namely classification and regression. So, next unsupervised learning. Unsupervised learning, as I told you, here I do not give any kind of assistance to the machine learning algorithm. I will not say this is apple, this is orange, I will not say, I will simply give the images. Can you see here? You can see there is a set of images, 2 images, cat and dog. Cat and dog. I am simply giving the images. The machine is itself able to create a model, but I am not going to give any label. I am not going to say whether it is cat or dog. So, seeing this, seeing the features itself, the machine is on its own able to classify these two into 2 clusters or 2 categories, namely cat and dog. And because it is doing clustering, we call this as clustering algorithm. Okay, it is called as clustering algorithm. Next is reinforcement learning. Reinforcement learning is a feedback based learning method in which a learned agent gets a reward for each right action and gets a penalty for each wrong action. So, what is the meaning of this? See here, it is like time series analysis. It is like time series analysis, like chess. You are playing chess board, right? What is what do you do in chess? In chess, what we do? We move here. Now, this is my current state. From here, suppose I am a queen, I can move this direction or this direction. So, on the current state, based on the current state, I will decide my next state of action. I will either move here or either move here or either move here. So, now this is my current state. So, now based on the opponent how he is playing the chess, I will able to move back, or I will move this direction, or I will move this direction. So, this is what I mean by reinforcement learning. So, reinforcement learning, there is no supervisor. So, I will be it is a kind of feedback based learning method. So, what I do, I take some action. When I take take that action, they will say it is wrong or right. Okay, they will say wrong or right. So, if it is wrong means what I will do, I will try to make my actions different. When it is wrong means I will be able to make my action different. So, this is a kind of a feedback based learning. Okay. So, the agent learns automatically with these feedbacks and improves its performance. So, nobody is going to say you are right or wrong, you are right or wrong, you will be given reward, like you will be given some points, your score will increase or your score will decrease. So, from which we can understand, okay, whatever movement I am doing is wrong, then accordingly you will have to change your action. So, this is an action based, or it is called time series kind of. First at time t1 I am here, at time t2 I am somewhere here, at time t3 I am somewhere here. So, every the next state depends upon the previous state or the current state. Okay. Then if you take as I told you, supervised learning, we will have the class labels given to the machine based on that is able to learn. Okay. When you take supervised learning, there are 2 types of supervised learning, one is regression, other one is classification. So, what is regression? Regression is used in the case of continuous variable. So, continuous variables means what? Like which changes rapidly. So, we do not have a single value. For example, you have got your age is today 11, then 12, 11 years 6 months. So, it is changing variable, it is called continuous variable. There is some variable called categorical variable. Categorical variable only 2 class, male or female, maximum 4 flowers, a number of flowers can be say 10, 20 flowers or 100 flowers. So, there is some numbers, right. For example, fruits means apple, orange, banana, we can have only 10 or 15 classes of fruits. So, that is called as categorical, which can be classified. These are called categorical variable. Certain variables are continuous variable, time, okay, time changes 12, 12.1, 12.2 keeps on changing. So, these are certain things are continuous variable. So, regression analysis is used in the case of continuous variable, and classification is done in the case of categorical variable. So, here what is regression means? Regression is going to predict something based on past data or independent data. For example, here in this case, in this table you can see that here we have got some advertisement, the company is making some advertisement for $90, the sales is like this, okay. He is making for 120, the sales is like this. So, he is varying the advertisement cost, and accordingly he wants to suppose I make investment of $200, what would be my sales. So, this is what I mean by regression analysis. So, this is your independent variable, advertisement cost is an independent variable, and accordingly sales is dependent. Sales is dependent on your advertisement cost, okay. Sales is dependent on your advertisement cost. So, how your cost is going to vary based on your advertisement. Here there are not only advertisement is one independent variable, we have got several independent variables. For example, your shop area, your company name, your logo, your brand, etc. All these also comes into not only based on advertisement, your sales is going to improve. Sales is going to improve based on your brand, your logo, your company location, your what you call your showroom, etc., etc., the showroom, the ethics of your showroom, accessories of your showroom, everything based on that your sales is going to increase. Not only advertisement is going to improve your sales. So, it is one of the independent variable, there are several independent variable. So, keeping other independent variable constant, if you are going to vary the advertisement cost, what is your sales? That is what I mean by regression. Okay. So, this type of problem is called as regression analysis, and types of regression we have got linear regression, polynomial regression, like this we have got several types of regression problems. Okay. As I told you, regression is used only in the case of continuous values. Okay. So, when I talk about a linear regression, I will just give an idea of what is a linear. Linear is I am trying to, I told you we have to find a function f is equal to y of x, we have to find a function f is equal to y of x, f is your function. So, this is a straight line function. Can you see I have got a straight line function here. When I have a function as a straight line separating the 2 points or lying close to the 2 points, we call linear regression. That is, the point should be closer to the line. For example, I have like this, a point is here, a point is here, the distance between the line and the point should be less. The distance between the point and the line should be less. That is, so that way I should be able to find out a function. That way I will be able to find out a function. So, what is logistic regression? Logistic, the equation varies. I have to put the 1 by 1 plus e power, that equation I have to use. So, in this case linear means y is equal to mx plus c, that equation you have to apply for linear regression. For this I have to approximate this equation 1 by 1 plus e power minus x, and this is the polynomial regression. So, this is the curve you have to get. So, data should be lying close to the curve. So, similarly in this case data should be lying close to the curve. So, this is called as polynomial regression. The only thing, the equation is going to vary, that is all, the equation is going to vary. Okay. And support vector machine, so need not bother about all those things to get an idea. So, our idea is to find out a function, that is the basic thing you should understand. Idea is to find out a function f, okay, so that it is a function of x. The distance between data points and line tells whether a model has captured a strong relationship or not. Suppose your data points are not lying on the towards the line to somewhere here, means then this function is not able to capture the relationship. So, I should find out a function, function means a line or a polynomial line or a logistical line that should be able to separate the two data, that should be able to lie close to the data and so on. So, based on whether I am using a straight line kind of thing, we call this a linear classifier regressor, or this is a logistic regressor, a polynomial regressor and so on. Okay. So, similarly we have got a decision tree regressor, random forest regressor and so on. Next is under supervised learning, we saw we have got two categories, regression and classification. So, what is classification? Classification in regression algorithm as I told you, we predict the outcomes for continuous values, but in the case of classification we go for categorical values. Okay. A classification algorithm is also a kind of supervised learning algorithm. So, classification can be either binary classification or it can be multi-label classification. For example, I can simply say yes or no, two classes, yes or no, 0 or 1, spam or not spam, cat or dog, like this we can give classification. Here this is categorical value. So, hope you understood what is categorical value and continuous values. Okay. And classes can be, as I told you, classes are called as labels or targets or categories. And as I told you, binary classifier only having two kind of classes, yes or no, male or female, spam or not spam, cat or dog, etc. Multi-class classifier, it has got more than one class. For example, I have 4 classes like apple, orange, banana, grapes. So, I have got 4 classes, then it is called multi-class classifier. Okay. Okay. So, here we can see this diagram, this is 2 class, the crosses are in, this is the function I have found out, I have obtained the function f, all data points lying this side are one class, all data points lying this side belongs to some other class. Similarly, here you can see these squares are one class, I am able to create the functions, this is the function for f green class, this is the function for red class and this is the function for blue. I told you model. So, I have created 3 models. Okay. So, function for f class, the green class, red class and blue class, I am able to separate these 3 objects. Okay. Hope you understood. And I will make you understand what is a linear model. Linear model, as I told you, I can find out a function which is nothing but like a straight line. The equation phi is equal to mx plus c. Okay. Sorry, y is equal to mx plus c, something like that. So, this is I am finding out a function which is linear means straight line, linearly separating two set of data. Here if you see here, I cannot put a straight line. Suppose I am going to put a straight line, some blue balls will be coming on this direction and some green will be lying on this direction. Okay. Wherever I put a line, once again some green is lying in this direction, green is lying in this direction. So, I am not able to find out a function which can separate the green dots and the blue dots. So, what I am trying to do, I am putting a circle, say within the circle all are blue and outside the circle all are green. So, in this case it is not linear. Linear means it should be in the form of a straight line. Okay. So, similarly here this is a linear. Can you say here it is not linear because I am having what logistic kind of a curve here, I am not having a straight line, I am having a logistic kind of a, so this is non-linear. Hope you understood. And linear models are regression models and support vector machines, and non-linear models we have got other classifiers like k nearest neighbors, naive Bayes, decision tree classifier, random forest classifier, all these comes under non-linear kind of classifiers. Okay. Then once you have done the classification, how are you going to evaluate the model? So, once the model is completed, we should be able to understand whether the model is done good, whether performance is good or not, and how are you going to do it. That is done using some loss calculation. So, we have to find out something called log loss or cross entropy loss. That is some calculation, some formula we have to apply, and that is a probability value between 0 and 1. If you are going to have a lesser value means, then it means indicate accuracy is good, a model is good, whatever model you have created is good. Next is using confusion matrix. So, what is confusion matrix? Confusion matrix is going to say, for example, this table you can see. So, for example, this is a tumor. Okay, this is a tumor. So, this is, we assume one image having a tumor, one image having something else, it is not a tumor. Okay, it is not a tumor. So, I am going this giving this to the machine, the machine says yes, it is tumor. So, it is true positive, it is called, it has got a tumor. So, it is assuming this is positive and this is, it is not having tumor, this be negative. Okay, initially it is negative and this is positive. I am giving this machine to the image to the machine, machine also says positive means it is true positive. Suppose I am giving this to the machine, machine says negative means what? There is a tumor, but the machine says it is not a tumor means what? It is false negative, it is a wrong negative, it is a false negative. Okay, that is your true positive, false negative. And suppose this is a negative image, there is no tumor here, I am going to give this to the machine says negative, there is no tumor, then it is called true negative. Okay, the machine also says negative, it is actually negative, machine also says negative. So, it is what? True negative. Suppose the machine says this to be positive, what happens? This is a false positive, it is not a original positive, it is a false positive. This is what I mean by. So, using this we can create a table and we call this as a confusion matrix, we call that to be a confusion matrix. So, given the input we can find out this table for how many images the machine is saying true positive, true negative. Using this I can make some calculation and accuracy is based on this true positive and true negative values, you can do some calculation. So, these are some formulas available, you not worry about that. And one more metric, how you can evaluate a model. So, once you have created a model, we have to find out whether the model is good or not. So, how are you going to do that? That is your AUC ROC curve. So, once again you can study on it later when we go for higher classes. This is one other metric for evaluating a model. Okay. So, now as I told you, we have got linear classifiers, non-linear classifiers, we have got supervised algorithms, unsupervised algorithms and so on. So, we have got SVM is one classifier, neural networks, all these are machine learning classifiers, right. Naive Bayes, Bayesian network, logistic regression, randomized forest, boosted decision trees, k nearest neighbor, etc., etc. And some of the use cases where we can use classification algorithms include email spam detection, speech recognition, identification of cancer, tumor cells, drug classification, biometric identification, etc. There are so many areas in which you can make use of classification algorithm. Once again the question comes, where to use what, which algorithm I can use where. So, depending upon your domain, depending upon your application, your requirement, you can choose any of these. There is no any hard fast and rule, but certain classification algorithm will be used for linear data, certain will be useful for this data, what data? Non-linear data and so on. So, you have to identify your domain, your area, and then accordingly you will be able to use it. Okay. So, which is the best one, the same thing we discussed now. Then advantages of supervised algorithm. As we know supervised algorithm, we know the label. So, we say we teach the machine, okay, see this is apple, this is apple. So, I will always give the label to the machine, I will able to train the machine, that is the advantage. So, what is the disadvantage? So, suppose it is very complex learning, that is very difficult using supervised learning, okay, and you should always give same test data, train data, whatever training we are giving, similar test data we should give, otherwise the machine will not be able to recognize it. So, it requires a lot of computation time, because every time you are trained using the labels, we have to take a lot of computational time. So, there are each type has got its own advantages and disadvantages. Okay. And when you go to, so far you have seen supervised data, now we go on to the unsupervised data, where we have got two types of technique, namely clustering and association. So, what is clustering and what is association? So, when I say clustering means, here with this image you can understand we have got strawberries and strawberries and lemons and apples, we have got three kinds. In the previous case, what we did in the case of supervised algorithm, we gave the label also. We told the machine, okay, see this is apple, and we gave the apple features, the machine was able to create a model. In this case, I am not going to give any label, simply I will be giving all the image inputs to the machine. The machine based, it is based on its own algorithm and own training, or not training we call it, based on its own classification methodologies, it is able to cluster them into apple, cluster them into lemons and cluster them into strawberries. Can you see here? So, I am not going to give any labels, it is automatically doing the clustering. Okay. And uses of clustering, it is used in market segmentation, statistical data analysis, social network analysis, image segmentation, etc. So, you know what is social network. So, today we have got social network, you can analyze what kind of users are using it, what is their sentiment analysis, all these can be done using clustering techniques. Okay. For example, if you take Amazon, the Amazon, they are giving some recommendation system. So, when I am going to buy a product in Amazon.com, so based on my purchase, what will do? It will able to understand my requirement, okay, you can also buy this. People bought this, also bought this. That way they are going to give some recommendation to me based on my purchase pattern, okay, what I am buying today. So, tomorrow I may need this, accordingly it is going to give me some recommendations. So, all these are done by using clustering techniques only. And similarly, for Netflix, we know Netflix is a movie what to call a portal where you can see movies. So, based on your previous watch history, what movies you are seeing, Netflix is also going to recommend the movies for you. Okay. And when you talk about clustering methods, there are two types of clustering, hard clustering and soft clustering. Hard clustering means, for example, we have got some data, assume like this, some data points. Okay. So, I am having one center here, one center here. Okay. Assume like this. Suppose I have a point here, I have a point here, I will put a cross here, I have a point here. I want to know whether this cross belong to this cluster or this cluster. So, both are midway. Okay. This point is midway between this point as well as this point. I want to know whether this belongs to this cluster, this cross here belongs to this cluster or this cluster. How do you decide that? How do you decide that? So, in the case of hard clustering, what I do is that I say it belongs to this cluster, say C1 and this is C2. This point midway, it is in midway, but still I say that this belongs to this cluster. Okay. And similarly, I say that this point does not belong to this cluster. So, it is hard assignment, I am simply assigning this point, but it is midway only. I can either say it belongs to C1, it can also belong to C2, okay. But I do not do that, I simply say that point x belongs to C1 cluster and it has got no relationship with C2 cluster. But in the case of soft clustering, what we do is that I say that the point x has 80% membership in C1 and around 20% membership in C2. So, that way I can give some sort of a fuzzy kind of belonging. So, I can say that the x belongs 80% to C1 and 20% to C2. In the case of hard cluster, what I say, x is 100% belonging to C1 and x is 0% belonging to C2, that is your hard clustering. So, I given exactly say belong to this or that, I do not have any kind of fuzziness in the case of hard clustering. So, this is about clustering. And types of hard clustering, if you take, there is partitioning clustering and hierarchical clustering. Partitioning clustering, the figure itself you can see we are partitioning the data. So, all blue belongs to one cluster, all green another cluster, red another cluster and gray another cluster. So, we are trying to have a partition, but in the case of hierarchical we can see we have got a tree structure. Okay. So, we are dividing the data into two groups, once again into two groups and finally, we are having red all together to one area, blue as one partition and hierarchy clustering, and then green as other, data as another group. So, this is kind of a tree structure. Okay. So, partitioning clustering is an example of k-means clustering algorithm and hierarchical clustering example of agglomerative hierarchical algorithms. These algorithms will be used in your machine learning methods when you do clustering. So, what particular hierarchical clustering, whether you are going to use k-means clustering, you are going to use fuzzy c-means, you are going to use, all these depends upon the type of data on which you are going to operate. Next is unsupervised learning. We have finished clustering. So, first we saw supervised clustering where we had regression as well as classification. Next we have unsupervised learning where we have got clustering and association. Now, we will move on to association. Association is like this: if A then B, if A then B. There is a relationship between A and B. For example, you see this example, people who buy the item X, suppose bread, also tend to purchase Y, butter item. Okay. Suppose I am buying bread means definitely I may buy jam or butter. So, this is what is called as association data. We have some kind of association to identify the relationship between variables. Okay. The association rule learning works on the concept of if and else statement. If A then B, if A then B, if else, if he goes he may buy, he may not buy, that way it is called association learning. So, once again, what is the disadvantage of unsupervised learning? Unsupervised learning is used for more complex tasks as compared to supervised learning, because in unsupervised learning we do not have labeled input data. So, here I do not have any label. So, I can do complex operations, I can easily do, but sometimes it is less accurate because I do not have any supervision, I am not training the machine with my labeled data, it might be less accurate. Okay. This is a disadvantage. And last one is reinforcement learning. Reinforcement learning, as I told you, is used in chess. It is used in chess. Chess, we have got a chess play, no? Playing chess using computers. So, here what happens? This is the person, this person has to reach this portion. So, from this state he has to move to this state. Suppose he is going to move to this state, means he is going to get a punishment, penalty, because he is making a wrong move. He has to move in this direction. Okay. Then he has to, suppose he moves here, okay, no issues, but when he is going to move here, this is a wrong move. So, every time he makes a wrong move, he will be penalized or he will be punished. Punish means he will have some lower scores. Okay. Scores will be reduced, a count will be incremented or decremented. Suppose he is making a right move, he will be rewarded. So, based on this reward, that is a feedback, he is able to make the next move and so on. So, this is like from one state to another state, okay, one state to another state. Okay. So, main points in reinforcement learning: input is from an initial state from which the model will start. Okay. Output, there are many possible output, but when you go to a wrong output, you will be getting a reward or a punishment. Okay. The model keeps continuing to learn. The best solution is decided based on the maximum reward. So, when you are going to get the maximum reward, you have got the best solution. Okay. And as I told you, reinforcement learning is used in chess games, and supervised learning is used in object recognition and other computer vision applications. Okay. Then practical applications of reinforcement learning: it can be used in robotics for industrial automation, it can be used in machine learning and data processing, it can be used to create training systems that provide custom instruction. See, for example, based on the requirement of student. So, what I can do is I can see how the student is progressing. So, I can decide, I can analyze how the student is progressing, and accordingly I will give him study materials. So, custom instructions and materials. So, suppose he is a fast learner, I can give him good materials, further materials. Suppose he is a slow learner, I can give him simple materials. So, based on that I can create systems which can provide custom information and instructions and materials to the people. Okay. So, one more term we should understand with respect to machine learning is generalization. So, what is generalization? Generalization is nothing that, so after training, so this is the training samples I am giving. After training, the machine is going to create a model. So, once the model is created, I need not give the same data taken from the training sample. Okay. This is data taken from the training sample. If I give data from the training sample, machine will be able to generalize better. But suppose I am going to give some new data like this, it is not in this training sample, it is a new data. If the machine is still able to generalize, then I say it is good, it is a good model. So, I should not give test labels from the own trained data, instead I give a new data, still the machine is able to generalize, then I say it is a good model. Okay. And next one is, there is one more important points in terms of machine learning you should understand. What is underfitting and overfitting? See, this is a data here, we have got two classes of data, one is blue, another one is red color star. Okay. So, here we can see a blue line, that blue line is trying to separate or categorize the two data as star and round, but if you take this line, some round is lying in this direction. Can you see? Some round is lying in this direction, and you take here some cross are also lying in the other direction, other side, other surface. So, what does it indicate? The machine is not able to correctly classify these two data. It is not able to exactly classify. It is not 100% accurate, because some crosses has been classified as blue colors and blue has been classified as crosses. This is wrong, because this function is not a correct function. The function f which is obtained is not a correct function. So, now we will see this function. So, this is also a function, but this function is not a linear function. You can see it is not straight line, it is some curve, okay, some curve, polynomial curve. So, here we can see it is somewhat better. We can see in this side all x's are present, but here we have got 2x in the blue area. Can you see? We have got 2 x's in the blue area. What does it indicate? It is somewhat appropriate. It is fitting better, to some extent better, but still there is some misclassification. Now, see what happens about this one. See this function f. This function f is more complex. You can see it is more complex, very difficult to obtain this function, but still I can see all the blues are lying in one side and all the crosses are lying in the other side. All the blues are lying in one side and all the crosses are lying in the other side. This is called as overfitting. The meaning is that for this particular data, this particular thing will work, this particular function will work. Suppose slightly I am going to modify the data, the same function will not work. So, what we should do is, you should not go for overfitting. If you go for overfitting, this data will work only for training samples. Whatever data you are going to give for training, for that training sample, this particular data will work. Suppose you are going to get totally new data, as I told you in the earlier slide, it is not possible to get the generalization. So, in this case it is somewhat better, okay. But if you take this is underfitting, so it will give always wrong results, always it will say red to be blue and blue to be red. It always misclassification always occur in the case of underfitting. If you go for overfitting, what happens? It will work only for that training sample. If you go for a different sample, that particular model will not work. So, this model is somewhat better. So, it is appropriately fitting. To some extent, it is not bad, it is not bad, okay. So, when you have underfitting, we call as high bias. When you got overfitting, we call this as high variance, okay. High bias and high variance. It's high bias or low variance, high variance or low bias, other way around, okay. As I told you, underfitting. So, whenever you have underfitting means what the algorithm does not fit the data well enough. So, it usually happens when you have less data to build an accurate model. So, in this case we can say the data is very less in building. So, when you got more number of data, maybe your model will be good. So, we should have more number of data, and also we should try to build, we should not try to build using a non-linear data, okay. So, in the case if you are going to build a data with a non-linear data means we will have lot of wrong predictions, we will have wrong predictions. So, underfitting can be avoided by using more data. And in nutshell we can say underfitting means high bias and low variance, okay, or high there will be error both in training as well as testing. There will be high training error as well as high testing error, okay. So, next is overfitting. Overfitting means when there is more number of data, it will be overfitted. So, it will so even it will try to learn from outliers, noise, etc., etc. It will try to learn. It will always be correct only for the training sample, or if you go give a new sample, it will not work, okay. So, in nutshell, overfitting, high variance and low bias, and it will have low training. As I told you, training error will be very low, because that for that particular training it will work well, but when you go for a new test data, test error will be very high, okay. So, we have to stop the training very early itself. Do not keep on training, early stopping during training phase, because loss begins to increase. Whenever loss begins to increase, you have to stop training, okay. So, this is about overfitting. And as I told you, we have to find out the capacity or the how much amount of data you are going to give for your model. So, this is a data samples, how many samples you are going to give for a model. So, we have to find out where there is a low bias and where there is a low variance. I have to find this point, after which the bias becomes very low, after which the variance becomes very high, okay. You can see this green color is the variance and blue color is the bias. So, we have to find out a point. Here this is the point here, can you see this is a point, this point is the optimal capacity, is the optimal capacity, okay. We have to find a point where the bias is low as well as the variance is low. So, after this point the variance starts increasing, you can see the green line, and after that point the bias is going to decrease, that is your blue line. So, you have to find out a particular trade off, okay. And this is the overall summary. So, what you have learned today. So, machine learning, there is two types, one is conventional machine learning, another one is a deep learning. I told you in the first slide everything comes under AI, machine learning is subset of AI and deep learning is subset of machine learning. So, deep learning or machine learning algorithm that make only use of neural networks, okay. Deep learning or machine learning algorithm that make only use of neural networks. So, conventional machine learning, normally it is classified into three types, namely supervised machine learning, unsupervised machine learning and reinforcement learning. So, under supervised machine learning we can work on two different data, one is continuous data, another one is categorical data. When you are working on continuous data, we call that to be regression, and regression once again we have got logistic regression, random tree regression, SVM, so many regression is there. And under when you are going to work on categorical data, it is called as classification. We have got logistic regression, support vector machine and etc., etc. is available under classification. And unsupervised machine learning, once again we have classified that into two types, clustering and association learning. Clustering learning, we saw that K-means clustering or hard clustering and soft clustering, hierarchical clustering and so on. There are so many techniques under that. And finally, we saw what is reinforcement learning. Reinforcement learning is a time series data analysis, okay, where the next state is based on the current state, and whatever whatever action you take is based on some reward or punishment. Okay. So, what to remember about machine learning algorithms? So, what we understood so far, machine learning algorithms is trying to do what human beings can do using some algorithms based on some historical data given to it for training. It is getting trained and models are created, and once a model is, what is a model? Once again, model is nothing but a function which is using the input samples, it is able to arrive at the target output. So, I have to arrive at a function. A function can be a linear function, it can be a polynomial function, it can be a logistic function, whatever function it is, you have to arrive at a function. So, for arriving at that function, we have to have several samples, that is what we saw. So, what machine learning algorithm you have to use for a particular application, it depends upon your requirement. There is no any dogmas. What is a dogma? A belief or set of beliefs that people are expected to accept as true without questioning. So, something we do not question, no, you do not go there, I will not question, you do not do this, I will not question. It is not like that. You can use any algorithm you want, wherever you want, as per your requirement, but depending upon your domain, your, for example, the feature is going to vary. For example, I want to find out whether it is a cat or a dog, then I have to use different features. Whether I want to find that to be an apple or orange, I have to use a different feature, and so on. So, based upon your domain, the features are going to vary. Based upon your domain, your classification algorithm, whether I will go for clustering, whether I go for regression, whether I go for this, based upon your data, it is going to vary. There is no any hard and fast rule. Okay. No free lunch theorem. What is free lunch theorem? There is no single best machine learning algorithm for predictive modeling problems such as classification and regression. I cannot say this is best, this is worst, this is best. There is no single best machine learning algorithm. That is called no free lunch theorem. So, I cannot say this is good, that is good. I can try all sort of possibilities and probabilities and combinations. Try simple classifiers first. So, we start with simple classifiers like SVM, which are very easy to do, and then we can combine classifiers. You can go for cascading of classifiers. We can try all sort of combinations. Better to have smart features and simple classifiers than simple features and smart classifiers. Yes, features should be very important. Then only whatever classification result you are going to get is going to be good. Use increasingly powerful classifiers with more training data. So, when you have got more training data, then you go for powerful classifiers and make sure that there is a bias variance trade off. I told you what is bias, it is overfitting and underfitting. So, you shouldn't have overfitting, you shouldn't have underfitting, you should have that bias variance trade off. And with this, we come to the end of this video lesson on this one machine learning basics. I thank you all and wish you all success in all your endeavors. Thank you so much. Thank you.